Hi everyone, we have already discussed the fundamentals of set theory. Let us discuss certain questions on set theory and how the different forms of set can be represented. So we have first example right here which actually shows write the solution set of an equation x square plus x minus 2 is equal to 0 in the roster form. So we all know, we already understand that roster is a tabular kind of format in which all the elements are supposed to be listed one by one, separated by a comma. And this set is supposed to be a solution set of this equation. That means I need to solve this equation first, and after that whatever solution comes out, that need to be represented in the roster form. So let us solve the equation first, which I think algebraically is very easy. So you have this equation x square plus x minus 2 is equal to 0. And if you see, you can use the simple factor method. That means factorizing 2 in such a way that their differentiation is going to come out to be 1 because the multiplier of x is 1. So if I start factorizing, then it is 2 minus 1, 2 1 are 2 and 2 minus 1 is 1 times x minus 2 is equal to 0. Further, x square plus, you're going to multiply x inside, so it is going to be 2x minus x minus 2 is equal to 0. I'm going to take x common out from these two terms, so that is going to remain x plus 2. I'm going to take minus 1 common out from here, so you can write it this way. It is simply going to remain x plus 2 because I have taken negative outside, so this sign is going to change. So you can always cross check by opening the bracket. Once you open the bracket, minus 1 gets multiplied inside, and that becomes minus x minus 2 is equal to 0. Now I'm going to take out of this entire argument x plus 2 common, so the value out of this remains x minus 1 is equal to 0. I'm going to put both these factors one by one equal to 0. So if I put x plus 2 is equal to 0, I do get x is equal to negative 2. Same way, when I put x minus 1, which is this factor right here, equal to 0, then I'm going to get x is equal to 1. So the solution of this equation contains two elements. One is minus 2 and other is 1. So the solution set for this equation, let's say, is represented by s, can be given by minus 2 and 1. So this is the solution to this particular question. That means I need to solve the equation, just learn the steps, and after that the solution is supposed to be whatever solution I'm going to get, I'm going to put them separated by a comma. Let's see another question. Write the set x such that x is a positive integer and x square is less than 40. And we're going to write, let's say, this particular set again in a roster form. That means we are going to list the elements one by one. So I know what are positive integers. So positive integers are, what are positive integers? They are plus 1, plus 2, plus 3, and so on. So these are the positive integers. So it says x is a positive integer. That means I have to start from 1. And x square is less than 40. That means I'm going to keep on squaring these numbers. But moment the square becomes equal to 40 or more than 40, I'm going to stop it there. So let us represent that particular set. So I'm going to represent that set, let's say, by I square. Seems much more better. So what is first positive integer? Plus 1. It is a member of set because its square is less than 40. Second integer is plus 2. Its square, 2 square is 4, which is again less than 40. Third integer is plus 3 in the number sequence. Square of 3 is 9, which is less than 40. The fourth number is 4. So you can check 4 square is again less than 40 because 4 square is 16. Then I'm to write next integer after 4, 5 comes. Square of 5 is 25, which is less than 40. Then I'm going to write 6. Square of 6 is again 36, which is less than 40. But if I write 7, the square of 7 is going to be 49, which is more than 40. So I'm going to stop here and this will become my set. So you can again check square of 1 is 1, square of 2 is 4, square of 3 is 9, square of 4 is 16, square of 5 is 25, square of 6 is 36. All these squares of these elements are less than 40. So all these integers whose square is less than 40 will become the member of this set. Let's see another example. Write a set A is equal to 1, 4, 6, 1, 4, 9, 16, 25 in set builder form. Set builder form is simply when you represent the entire all the elements of a set by a common variable and associate that particular variable by the property. So if you see, I just need to understand the pattern here. One is what is 1, what is 4, what is 9, what is 16. It's pretty simple to understand. 1 square is 1, 2 square is 4, 3 square is 9, 16 square is 4. So this set is becoming 1, 2, 3, 4. So let's see how exactly I'm going to write it. Set A is equal to x such that, what is the property of x? X is a square of a natural number less than or equal to 5. Very important. That means this set is stopping at 25. So less than and equal to 5. So if I rewrite this set, x is square of a natural number. So what are natural numbers? So let's see. Natural numbers are 1, 2, 3, 4, 5 and so on. And what is set A? It is square of natural numbers. So 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16 and so on. And what is the largest where it is stopping at 25? So largest number I can take is 5. So x such that x is square of a natural number less than 5. We can write it more mathematical. It can be simply x such that x is equal to n. Why I am writing small n? Why I am writing small n? Because small n represents the natural number. X such that x is equal to n square such that n belongs to n. That means n is a natural number which is less than equal to 5. So this is much means more mathematically you can write it this way. X such that x is equal to n square, n belongs to n such that and n less than equal to 5. So simply I'm trying to put it that way. So mathematically, you can express it multiple ways, and you can write it means or more refined way is something like this: x such that x is equal to n square such that n belongs to n and n is less than equal to 5. So you can write it this way also. Means this is highly mathematical. All three forms are correct. Some people may argue that this particular argument written the way it is not showing a correct picture because capital N is less than equal to 5. So you can avoid that. But I think this particular form and this particular form are absolutely correct. You can write them up. Let's see one more example. Write set A is equal to 1 by 2, 2 by 3, 3 by 4, 4 by 5 in a set builder form. This is a comma right here. So if you see, the denominator is one number greater than the numerator, and the numerators is a simply natural number sequence. So how you can write it? So you can write it simply like this: A is equal to x such that x is equal to n upon n plus 1 and n belongs to n. Now I did not put any upper cap on it because it is continuously going on. So you can cross check it if you put n equal to 1. So what are natural numbers? I'm writing it again. natural numbers are 1, 2, 3, and so on. This is represented by capital N. So natural numbers are 1, 2, 3, and so on. And if you are trying to write a set A here, so look, replace small n by 1. So 1 upon 1 plus 1 is this is first element. Replace n by 2. So 2 upon 2 plus 1. Then n by 3. So 3 upon 3 plus 1. And so on. You can keep on doing it. And what you are going to get is 1 by 2, 2 by 3, 3 by 4, and so on. So if you see, this is exactly same as this set. So this is the answer in a set builder form. You can write it this way. So please practice these examples. You can, okay, I'm going to write a question here. You can simply practice it something like, okay, let me put a question through that write a set A is equal to 1 and let's say 8, 27, 64, and so on in set builder form. So try to calculate this particular example. Let's have more examples of set theory in next video. Thank you very much.